Okay, we want to find the domain of the given functions. So remember there are only two domain rules. The first rule being that you cannot divide by 0. So I see in this very first one that we have a denominator. We have to make sure that x squared minus 9 is not equal to 0. That means x squared cannot be equal to 9. Now we would take the square root of both sides. When you do that, you need a plus or minus, unless you know the answer has to be positive, but nothing here says the answer has to be positive. So we determine that x cannot be equal to either positive 3 or negative 3. If you want to see this in interval notation, if you're not sure how to do it, here's negative 3, here is 3. We don't want to include either one of these numbers, but we want to include everything else. That breaks this up into 3 separate intervals. So here's the interval notation. Negative infinity to negative 3. Then we go from negative 3 to 3. And then we go from 3 to infinity. Remember, the parentheses mean you do not include those numbers. Okay, so first rule, you cannot divide by 0. Now in the second problem here, we do not have a denominator, so we don't have to worry about dividing by 0. We do, however, have a square root. So the second rule is whatever is underneath the square root, which we call the radicand, has to be greater than or equal to 0. So now we need to solve this. So I'm going to start by subtracting 2 from both sides. And that's pretty straightforward. Now here's where the trick comes into play. The next thing we need to do is divide both sides by negative 1. Whenever you divide or multiply by a negative number, you need to reverse the inequality. So what this now becomes, of course the two negatives become positive, becomes x, not greater than, but less than or equal to positive 2. In interval notation, that's everything less than positive 2. Probably should have done this first. If you're having difficulty with this, draw it. We want to include 2. We want everything less than it. So it starts at negative infinity. It goes up to 2. Okay, now we have in part C, we do have a denominator. So we have to make sure that what is in the denominator is not equal to 0. Well, normally absolute value makes the quantity positive, with one exception. The absolute value of 0 is just 0. So the only thing that's going to make this denominator if x is equal to 0. So anything else is acceptable except 0. Now if you want to see this drawn out, whoops, that looks like a, need to do that a little bit bigger. There we go, it has to be a whole. So we want everything greater than 0 and everything less than 0. So in interval notation, negative infinity to 0 plus everything from 0 to infinity. Okay, you cannot divide by 0, you cannot take the square root of a negative number, which means whatever is under the radicand has to be positive. I lied. Has to be positive or 0. Okay. So now I gave you two functions and I've asked you to combine them. In this one I'm asking us to find f times g, which is going to be a new function. And this new function is found exactly the way you would expect it to be. We're going to take f of x and we're going to multiply g of x. So here's f of x, it's x cubed over x squared minus 9. We're going to multiply by g of x, which is x squared minus 9. Now look what happens. This can be simplified. I should put parentheses around this whole thing. These two quantities can be canceled. So it looks like when we find this new function, f times g of x, it is equal to x cubed. Okay, second question, find the domain. Now, when you go back up here and you look at the function we just found, so here's the function we just found, just glancing at that, it doesn't seem to have any domain restrictions. We're not dividing, We're not taking a square root, so we seem to be good to go. So it seems like the domain would be all real numbers. However, we are working with two functions, f and g. So recall, the rule is that we must be in the domain of f and in the domain of g. Now I don't want to spend a lot of time with the domain of f because we just found it in the previous problem. So for the domain of f, we just determined that x could not be equal to positive or negative 3. We did that earlier. For the domain of g, I look at that function g and it has no restrictions. So the domain is all real numbers. We have to be in both of them. So right here, g says anything's good to go, but unfortunately for f, we can't have 3 or negative 3. So we have to make sure that we satisfy both criteria. So what that means is, I'm going to come back up here, that domain is no longer correct. We are not allowed to have 3 or negative 3 because f does not let us have 3 or negative 3 in our domain. So the domain is actually everything excluding negative 3 and 3. Even though it doesn't look that way when we look at it, because we started off with f and g, we have to be in both domains. Okay. Now we have a lovely, not a very difficult function here, negative 2x squared plus 1. We want to first of all start with finding a difference quotient. So the hardest part of finding a difference quotient is, whoops, I don't really want red here, is finding f of x plus h. That is by far the hardest part. So I want to do that separately, but before I do this, I'm going to remind you that if you want to evaluate the function correctly, especially on this one, write the function with parentheses in place of every x. Now we can correctly evaluate it at x plus h by replacing each set of parentheses with x plus h. Now there's a lot of simplifying to do here. The most important one is that the x plus h squared, I'm going to go ahead and write it out twice. Can't believe I'm not just using the formula, but I'll write it out twice. And let me multiply these first. X times x is x squared. I get a positive xh when I do the outer two. The inner two is h times x, which I'll also write as x times h. And the last two is an h squared. So now let me distribute the negative 2, so we end up with negative 2x squared minus 2xh, minus another 2xh, I forgot I was going to combine those like terms, but we'll do that in a minute, minus 2h squared, and then we have a plus 1. So what I probably should have done earlier is put the xh's together before I distributed the negative 2, but I forgot to do that. So there we have it. So now let's come over and let's evaluate the difference quotient. So we want to take what we just found, we want to subtract the original function, and then we want to divide by h. So we have minus 2x squared minus 4xh minus 2h squared plus 1. We are going to subtract the original function, which is negative 2x squared plus 1. Notice I put parentheses so I don't forget to distribute the negative, and then we divide by h. So once we simplify this numerator, nothing hard about it, there's just a lot of terms. So let me distribute the negative, so that becomes a positive 2x squared and a negative 1. Now notice, the 2x squareds, one is negative 2, one is positive 2x squared, so they cancel. We have a plus 1 and a minus 1. They cancel. So here's what we are left with. Negative 4xh minus 2h squared, all of that is over h. If you will break it into two fractions before you do your canceling, you are not going to make a canceling mistake. So notice here the h's cancel. Here only one of the h's cancels. So what we're left with is minus 4x minus 2h. Minus 2h. So let me come and write this in here. This was equal to minus 4x minus 2h, right? Yes, minus 4x minus 2h. Okay, now for the average rate of change, this is simply slope. But notice I only gave you x values. Before we can find slope, we need to have 2 points. Since I gave you the x values, we have half of each point, we need to find the y value. Well, to get the y value, we need to find f of negative 2. Now once again, just so that I'm always consistent, I'm going to first of all write the function with empty parentheses in place of x. Now I can plug in, negative 2, and we can simplify and see what we get. So I get negative 2 times negative 2 squared is 4 plus 1. So that's negative 8 plus 1, which ends up being negative 7. So I now have my first point, negative 2, negative 7. When I want to evaluate the function at 1, again, I'm going to leave empty parentheses. This one you might not really need to do this, but just to be consistent, I'm going to put a 1 in each of these places. Obviously 1 squared is 1, so we get negative 2 times 1, which is negative 2, plus 1, so that ends up being a negative 1. Once we have the point, the average, or both points, excuse me, the average rate of change is simply slope. So I'm going to do negative 1, change in y, so negative 1 divided by negative 7 over 1, did I say divided by negative 1 minus negative 7 over 1 minus negative 2. Be careful with negatives. These two negatives become a positive. Negative 1 plus 7 is 6. Again, these two negatives become a positive. 1 plus 2 is 3. So after all is said and done, we get a nice average rate of change of 2. Not too bad there.